Hi again, I'm Mr. Hawkins, Head of Science at Thomas More Catholic School in Purley. Before I get started today, I want to talk and just to reiterate with you the message from the NHS. Stay at home, protect the NHS and save lives. Right, acids and alkalis. Today's success criteria. Understand what an acid and alkali is. Understand the colour change of some of the most commonly used indicators. Be able to calculate the concentration. Understand what is pH, but also what makes a strong acid. For those of you who use this video alongside your own studying, perhaps you might want to look at the Making a Soluble Salt video that I've already uploaded, and try and link what you get from this video with that. What is an acid? Acids form acidic solutions when they're dissolved in water. They have a pH of below 7. Acids dissociate into H+ ions when they dissolve in water. For those of you who are about to start Year 12 chemistry, you might want to look up the formation of this hydronium ion. The idea there is that the hydrogen combines, the H+ ion combines with water to form H3O+. Anyway, let's go back to GCSE and let's take hydrochloric acid, for example. Hydrochloric acid is shown here, it's hydrogen bonded to chlorine. When it's in an aqueous form, it splits into the H+, the hydrogen ion, and the negative chlorine ion. This is what makes it an acid, the H+. That is what makes any acid acidic. The H+ ion is the measure of the strength of this acid, which we'll come on to later. But that when we're addressing any topic about acids, you should be looking for the presence of the H+ ion. What is an alkali? Alkalis form alkaline solutions when they're dissolved in water. They have a pH of above 7. Alkalines form the OH-, the hydroxide ion, and this hydroxide ion is what makes the solution alkaline. If we look at NaOH, sodium hydroxide, I'm sure you've used that in your chemistry lessons. There's the bonding in sodium hydroxide. It breaks down in water to the Na+ ion, sodium plus ion, and the OH- ion. That is what makes the solution alkaline. This is known also as a polyatomic ion because it, as an ion, has a small covalent bond within it that holds it together as an ion. What you need to really remember here is that anything below 7 is acidic, anything above 7 is alkaline, and obviously 7 is neutral, it's neither acidic nor alkaline. Let's move on. What's an indicator? Now here I've put the indicator at the side of an Audi, just to kind of get you thinking. An indicator tells us something, it allows us to infer. But we're not interested in cars, we're interested in chemistry. So an indicator shows whether the solution is acidic, alkaline, or neutral. There are many different indicators, and a lot of household foods can be used as indicators, including turmeric or red cabbage. Bar universal indicator, they do not give you the pH. So do not mix up indicators with pH. Very common mistake and completely wrong. Here's a number of the key indicators that you need to know the colour changes for. Let me outline the ones that I think are most important. Universal indicator is obviously red in an acid, it's green at a neutral pH, and purple in alkaline. You need to know about phenolphthalein, which is the second one down. Phenolphthalein is pink in alkaline conditions and colourless in both neutral and acidic conditions. You also need to know methyl orange, which is red and then slowly transitions to the yellow at the point of being neutral or alkaline. The important thing here is that you'll see they don't allow you to infer the pH because the transition isn't necessarily at an exact point. Now, for those of you going on to do A-level chemistry, you will study that as part of your Year 12 course. How do you calculate the concentration of an acid? Well, there are a number of ways to do this, and perhaps the most fun way to do it is a titration against a known concentration or volume of alkaline solution. The second one is using a formula, which is unfortunately what we're going to do today. What I would like you to do before we move on is look at what is a concentrated solution, what is the opposite, a dilute solution, what is the formula to calculate concentration, and those of you who want a bit of a challenge, why are the units important here? Here's what you should have got. A concentrated solution contains a lot of solute per unit volume. So there's a lot of the species within that solution. So if we take a concentrated acid, for example, there would be lots of H+ ions in that solution. If it was a concentrated alkaline, there would be lots of OH- hydroxide ions in that solution. A dilute solution contains a small amount of solute per unit volume, the complete opposite. A weak acid would have very few hydrogen ions present in the solution. Concentration is calculated by the mass divided by the volume. Now, what you need to be aware of here is that the units can change. So the concentration could be, if you had a mass in grams, it could be in grams per dm cubed. It could be in cm cubed in a question. If it was in cm cubed, centimeters cubed, you would have to divide by 1,000 and convert to dm cubed, which is the standard units you should use here. It could be in moles per dm cubed. The key point is that you look at the question and you make sure the units marry. Let's move on. What is pH? pH is a measure of the concentration of H+ ions or hydrogen ions within a solution. Strong acids like hydrochloric acid, HCl, nitric acid, HNO3, or sulfuric acid, H2SO4, fully dissociate. So they break down. Going back to our example earlier, the dissociation takes place with hydrochloric acid and fully dissociates into H+ and Cl- when it's dissolved in water. You'll notice that the reaction is only going one way, it's not at all reversible. Weak acids, on the other hand, do not fully dissociate. Let's take a household example, ethanoic acid, which is in vinegar. Ethanoic acid here contains the C double bond OH group. This bit here makes it an organic acid. You'll notice the use of the reversible symbol because what happens is the ethanoic acid is not very good, is the words they've used on this website, which I've cited at the top, at dissociating. It doesn't fully dissociate into the H+, the hydrogen ion, and the ethanoate ion. So what that means is that at the same time as some H+ hydrogen ions are being formed, also some ethanoic acid is being formed. That is why it's a weak acid. It would have a higher pH. That's why you can put ethanoic acid on your chips. You couldn't put hydrochloric acid on your chips unless you wanted to be in hospital. Let's review the success criteria from today. Understand what an acid and alkali is, we've done that. We understand the colour change of some of the key indicators, we've done that. Be able to calculate concentration. Understand what the pH is and what makes a strong acid. Just to finish, stay at home, protect the NHS and save lives. Thank you very much.